My name is Zafiria Kostopoulou, and this is my assignment for the Machine Learning Foundations for Product Managers course from the Duke University. The brief was for us to predict the electrical energy output of a combined cycle power plant. We have the dataset, the given dataset, and four possible features for columns: ambient temperature, exhaust vacuum, ambient pressure, and relative humidity. We also had the target column, and we had to determine which of the four columns would be the real features for our model to be trained. Obviously, the choice for this model would be supervised machine learning because we had to train a predictive model. The brief called for the prediction of a numerical target variable by learning input-output relationships, which led to regression and especially linear regression. In order to determine the features, I ran correlations formulas, each column against 2p, and an R-squared formula, each column against 2p. The two first columns, temperature and vacuum, seem to be closely correlated to the target variable in a negative correlation, and have a good fit with it. The other two, the fit was too low, much below 0.50, so I didn't choose them. I went to the TensorFlow, and the training code called for linear regression, two neurons for the input features, one neuron for the target variable. The test size was determined as bigger from 0.2. The atom optimizer, epoch 64, batch size 64, and the loss function would be measured on mean squared error. The line of the loss and validation loss, the two lines started quite close one to the other, and they decreased quite steeply up to the 15th epoch. Then they converged and stayed stable together at this low level. This shows that our model has a good fit, a high learning capacity, not only working with old data, but with new data too. Then I tried to use the Google AutoML, but I kept receiving internal errors messages, so I changed to the Azure uh, environment, Microsoft Azure environment, with the specific dataset, two columns of the given two features and the target variable. The data guardrails show no problem with our dataset, no cardinality, no missing values. The validation type was auto-selected. It was the Monte Carlo cross validation for more confidence. And the system used in total 41 algorithms to train the model, which it validated with a normalized root squared mean squared error to determine the best model, which was the voting ensemble, a kind of linear regression algorithm, which performed the best and gave the lowest normalized root mean squared error. Here are more run metrics, explained variance and all the others, which show that our model can predict with accuracy and confidence. Thank you for your attendance.